Hey everyone. So today we will be starting making some basic projects on machine learning, and we will be going from basics to advanced projects. And for basic project, I've chosen this project which you can see on your screen, Employee Attrition Prediction Dataset. So basically, in this is a machine learning project, and our goal is to predict whether an employee is likely to leave the company or stay. So attrition basically means only that leaving. So here we are we will predict that if an employee is leaving a company or not. So before starting with this project, I would like to explain you some terms like this is a machine learning project. So we can start by understanding what is machine learning and what are its types. So it will be easy for you to later understand. So now coming to machine learning. So if I say machine learning is a branch of artificial intelligence that you all know that enables computer to learn patterns from data during training and use those patterns to make predictions or decisions on new data. So this is a definition of machine learning. You can Google it, you can find it anywhere. So machine learning is basically divided into two parts. First is supervised machine learning, ML, and second one is unsupervised machine learning. So whenever we are working with labeled data, it is always supervised machine learning. And whenever we are working with unlabeled data, it is unsupervised machine learning. How can we say over here that it is labeled data means columns are there, column name are there, it will be called as supervised machine learning. So supervised machine learning is also divided into two part classification. And please pardon my handwriting because I am writing in a notepad, but I trust me, you will I will explain you in such a way that you will understand every concept. Classification and regression. Unsupervised learning is clustering. Don't worry, I will be explaining all these terms. It will be a bit difficult for you right now, but once I will explain all these terms, it will become a piece of cake for you. So classification basically when our result is yes or no. For example, mail class. We have to predict a mail is a spam or not spam. So there can be only two category. A mail is spam or ham we say, but we can say not spam here because we are in between phase. Re Regression is basically when we get a numeric value, like house price prediction. Numeric value can 1.5. I'm saying numeric, not whole value. It can be of decimal also. It's not a big problem. Clustering is when you identify patterns. Like in this, you identify patterns that from here you can get that we are getting a triangle or square. So clustering is basically we are when we identify patterns. So now in this project, I have to I will now tell you what we have to do, and you have to tell me from here that which we will be using over here from all three. It is not like I will be just giving you a lecture and you will just listen. We will be having an interactive session in this. So what I told you that from this all these data sets, view more, all these columns, employee ID, age, gender, and number of companies, still attrition. We have to find that if a person is leaving a country or leaving a company or not. Is leaving or not. So you tell me that from all this, which from classification, regression, and clustering, which you will be using. Classification, leaving or not leaving. So, and here there are two possibilities. Two means binary. So I can say that this project is based on binary classification machine learning project, right? So this is a binary classification ML project. This is a very basic project, and who should watch this video and do this project? Any beginner who is for the first time doing machine learning, anyone who want to add a project in his or her resume. I will be explaining every step by step, every till the end, like which model we are using, which everything I will be explaining, and you can just understood. You can just understood from here, and you can upload it in your CV. Moreover, I will be giving you the all the dataset link. I will be giving you Google Colab link. I will be giving you GitHub link, and all these links where you can like download the IPYNB file, or you can just download the data set, and from the Google Colab you can see that what code I have written, and you can just understand it. Okay, so without further delay, let's start with it. And in like middle also I will be explaining. So I will make out some space here. Just a minute for, yeah, right. So now coming to this data set, and I will be making this on Google Colab. So I will go to Google, write Google Colab, and I will just go to Google Colab, new notebook. Yeah, I will connect it. For I will be making it public, so when I will be upload, you can just see this. And later on, I will copy the link and will give you in the description. All these things will links will be given you in the description. You can just see it from there. And so before starting, we in this binary classification problem, yes is basically employee leaving the company, and no is employee staying in the company. So by seeing all the columns, we have to predict that if a employee is leaving a company or not. Okay, so let's start with it. So we will be start with importing library, and I will be importing PD, and yeah, I will be explaining all this library. Don't worry about it. Import matplot as PNT. So this is the only one I am typing, because if I will type a whole code, it would be a very long video and it will become boring. So while it is being run, a cell is being executed, I will be explaining you. So basically, pandas is used for data manipulation. Whenever a data set come, we have to like do the analysis and all that. So in that, pandas is used. NPy is basically helps with numerical operations. Matplotlib and Seaborn are used for data visualization. Okay, so now coming to data loading. So we can just, there are two way to, so I will be coming here. Don't worry, I will give you this. So I will be, there are two ways. One is like buy link over here and the second download zip. But okay, I will just tell you. I copied this from here and here I will be writing loading data set. Yeah, and I will take another column. Here I will be like, so I have like from the link I have downloaded a data set. One option was also there like downloading the zip, but I would be not choosing that. It would be a better, it would be an option like from here I would be like copying the path and pasting it here, but I am not doing it because very important because this time it will work. But again, if I open it, you have to again re-upload the data set. And if you are like uploading the link, you don't have to do it. So my data set is like uh, on this path, and this code will tell you where the data set is being loaded. So there are two data set, one with 10,000 values and one is with 1,000 values. Currently, I would be working with 1,000 values. Why? Because right now we are learning, and if we will take 10,000 data set value, it would be take a very big time to be, load, and it would waste our time. So we will be currently taking this 1,000 values. So OS is operating system. Whenever you are working with terminal of a laptop and all that, we use this library. For root is basically to the path where we have like our my data set is load, and I will be here we are printing where it is being load. So these are the two paths which we got. df is equal to pd dot read csv. In every machine learning project, this is the line common, guys. I've done a numerous project, and every project we use this line. This means df is equal to pd dot read csv. csv is comma separated value. So pd is pandas short form. You can see over here pandas short form we have taken as pd. So pd dot read csv, like read this, and whole this data set is being saved in df right now. And in future you will see in the code we have been using df only, and this the pandas library is helping to reading this whole data set and saving all that in df. Understood right now, till right now? So uh, I will be now displaying the df dot head. Cool. So what does df dot head indicate? df dot head gives us the first five values of our data set. By default, it is five. Like if I write over here 10, so it will be giving me 10, first 10 values. But by convention, we take head of five values, and why we can't like I can't like 1,000 I be displaying over here, or 10,000 data set values I won't be displaying. Just for understanding the data set, I will be like taking first five values, and if you want to take the first last five values, you can just do tail over here, and you can see that you have got the tail. But we will be taking the head, and now I will be explaining you this data set. See, machine learning, understanding the data set is a very important thing. So we will be first focusing on the understanding the data set. We will be performing the EDA, exploratory data analysis. Like if there are any null values, we will be adjusting that and all that, but it is a later part. So like these are the things. Here we have employee ID, age, gender, matrix, department, and all that. And here we have attrition. So what does this mean? from all these columns, can I find out the attrition? Like because of the absenteeism, work environment, is a employee leaving the company? Like attrition is leaving or not? So here the first five hasn't left the company, and these were the details. So we have to find out right now. This only we will be using some algorithm like logistic regression, random forest, and all that. But it is on later no, part of the code. We will see that. So now we will be taking out the we will be doing the dataset information, and I will be writing here df.info, right? So here I have 1000 entries. I have taken the dataset having 1000 entries, not 10,000. So does the column employee ID has null values? No, 1000 not null. Does any of the column has null value? No. Here all are having values. That's why I've taken the basic. I've from many data set I find out the basic, like we don't have to do much more EDA over here because it would be very difficult for you to understand. It is a very basic project, so all the values are having not null over here. So this basically shows the number of rows, the number of columns, data type, missing values. You can see that data type over here is integer, object like string is there, and integer, string, all there, missing values. But here are no missing values. Okay. So we can see that the data set contains employee information such as age, salary, department, job satisfaction, overtime, and attrition. Now we will be checking if there are any missing values. I already told you that, but let's check it. Checking missing values. Dot is null sum. All are zero. That means missing values are not here. But missing values is a common issue in machine learning. Before building a model, we need to verify whether any columns contain null values. In our case, there are no missing values, which means no addition cleanup is required. So now we will be taking out what is a target column. And if you will be like following what I've been saying, I've already told it. But standing target variable. df dot yes, attrition is a target variable. From all the like from employee ID, from the overtime, is he working overtime and all that, we have to find if he has leaving the company or not. So again, I will go explain. From we have to find its gender, ma'am. Because of gender, is he leaving, micro status, and all that. We have to find out attrition over here. So, so means 811 have not left the company and 189 have left. So 81% haven't left and 19% have approximately left. So we can say that most employees stayed while a small number left. This indicates class imbalance which may affect model performance later. Now we will be like I have already told a percentage, but like here I have told because of 1000 data set was there. But if like 2 lakh, 3 lakh were there, I wouldn't have been calculated. So I would be taking out a percentage. And for the percentage code, I am like just writing it here. First, let me write the heading percentage distribution. 81% haven't left and 18.9% have left the company. So converting counts into percentages gives a better understanding of class distribution. Around 81% employees stayed and 19% left. This imbalance is important because accuracy alone may become misleading. Now coming to the one of the main things, EDA. EDA overtime versus attrition. Why overtime? Like I am to like from this column, if from this data set, if you say one of the main like factor can be if a person is working overtime. So let's see. So I will be comparing between overtime column and our attrition. Like, is overtime affecting attrition? Yes or no? So let me like let's run it here. So basically now we have begun with the exploratory data analysis. Our goal is to understand which factors may influence attrition. Here we are comparing overtime with attrition. As I told you right now, the normalized parameter converts count into percentages. Surprisingly, employees with overtime and without overtime have similar attrition rates. This suggests overtime may not be a strong predictor. No problem. We will go now to next column, which is job satisfaction. EDA of job satisfaction. Mm, So as you can see that values are ranging from 1 to 5 over here, where 1 indicate low satisfaction and 5 indicates high satisfaction. We are checking whether employees with lower satisfaction leave more uh, frequently, but I don't think so. Let's check it. Like which are very much satisfied, 19% are here, and which are not satisfied, very dissatisfied, 20%. Is there a big difference between them? No, it's just a 1% difference. So I can't say that job satisfaction may be a column for a employee to leave. Now, one thing, if you will come and see over here in this, like in this of finding column and all that of attrition, which column you think is useless? Just guess it. Employee ID, because it is not helping us out. Salary, if a person is leaving a company, think practically. If you are leaving a company, what can be the factor? If you are getting less pay, you are if the manager is making you working overtime, if you are taking too much leaves, and like job role, department, everything matters. But is your employee ID will matter? No. So what I can do is basically I can drop. I will be dropping the employee ID. Yeah, PLOYID. So have written axis is equal to 1 over here. What is this axis? So axis can be 0 or 1. Whenever we are deleting a column, we take axis as 1. And whenever we are deleting a row, we take axis as 0. Right now, employee ID is a column. So we are taking an axis is equal to 1 and we are deleted it. So now we will be doing df dot head over here. You will be seeing no employee ID column. Got it? So basically, this employer ID is simply a unique identifier. It does not contain any meaningful information about employee behavior. Therefore, we are removing before training our model. Next come a very important thing, separating features and targets. Separating features and target. What is our feature and target? If I just copy paste my code over here, will you able to understand? No. I've taken X here, Y here, axis, and why I am dropping attrition. Now I will make the things very clear too. From all these columns, we are predicting attrition. Got it? So what if I do like make all the, so basically all these columns are our question and attrition is our answer. Right now our data set is having all this column. I will just delete this column from here and make it another and make x except attrition. Our x will be all this column and y just attrition. So x is equal to y, like all these columns is equal to attrition. So all these columns are x and our attrition is y. Why? Because all this column will predict will is a result of attrition. Like a relationship with manager will be is equal to will be resulting in attrition. Job involvement will be resulting in attrition. So that's why I am doing over here x is equal to drop attrition, x is equal to 1. We are dropping column, we are taking x is equal to 1. Simple. Y is just attrition. X is all the columns except attritions and Y is just attritions over here. This is very important thing. So machine learning basically requires us to separate inputs and outputs. X contains all employee information, Y contains a target variable. So which is attrition. The model will learn the relationship between X and Y. Now we will be doing the encoding. Why I am doing this no is equal to 0, y is equal to 1? Simple. Machine learning algorithm cannot understand text values such as yes or no. So we are converting no is equal to 0 and y is equal to 1. Encoding is just 0 and 1. Encoding, one hot encoding and all is just 0 and 1. Now we will be seeing that what are the categorical columns present in our data set. Five categorical columns identified. Why we are choosing categorical columns? Can anyone, like, I will explain only. Because These are gender, male, female. Will the machine learning algorithm understand? No. Measure security? Yes, no. It will won't understand. That's why we have to convert them into 0 and 1. We have to do one hot encoding for them. That's why we are just finding out which are the columns which we will be doing the one hot encoding. So one hot encoding. Got it? X is equal to pd dot get dummies. Dummies all like it dumps, like it converts. So we use one hot encoding to convert categorical features into numerical form. We avoid label encoding because it introduces an artificial hierarchy. One hot encoding creates separate binary columns for each category. Now, basically, one of the very main thing, train test. Train test. So here we are using which library? We are using sklearn. This is also a very important library. Here we are using our xtrain xtest. So from x we will be taking 80, like 80% will be our training and 20% will be our testing. From y also 80% is our training and 20% is our testing. And one more thing, training is having all the columns and test is the attribute column. Here also it is all the no, like x is the like all the columns over here are here and here are the attributes. So we have taken 0.2 test size. So train size would be 0.8. We always we take more of training rather than testing. Okay. So to evaluate a model fairly, we split the data into training and testing set. 80% is used for learning and 20% is used for evaluation. So it ensures the class distribution remains similar in both sets. Now we will be using our first model, logistic regression. Logistic, logistic regression. So why logistic regression algorithm? Many algorithms are there, but it is the baseline model. We we use class weight. So right on the code. So we use class weight equal to balance because the data set is imbalanced right now. This forces the model to pay more attention to employees who leave. So, and next we will be doing the predictions. The model has now learned from the training data. We use the test data to generate prediction on previously unseen employees. Now we'll be making the confusion matrix. Very important thing, very important thing. Confusion matrix. So confusion matrix provide detailed information about model performance. It shows true positive, true negative, false positive, false negative, and this is more informative than accuracy alone. So I will be now generating the classification report. And so we will get a precision, recall, F1 score, support over here. So Here we are basically evaluating all this. Recall is especially important in this project because we want to identify employees who are likely to leave. Missing an employee who is about to leave may be costly for the company. Next algorithm which we'll be using is random forest. Forest. So random forest can capture more complex relationship features and interaction compared to logistic regression. And next we will be doing our feature importance. So basically, what does feature importance do? Let me show you. Yeah. So feature importance help us to understand which feature contribute most to the model decision. We have got it right now. In our project, monthly income, training hours, hourly rate, distance from home, age, years, and company are were mattering the most. And we were checking like in EDA different. So final verdict, what we can say. In this project, we build a complete employee attrition predictive system. We perform data cleaning, exploratory data analysis, feature engineering, model training, and evaluation. We learned that accuracy alone can be misleading and that recall is a critical medical metric attrition prediction. Finally, we identified the most influential feature affecting employee attrition. So this was the project, and I haven't given the heading it right. I forgot to give the heading. So employee employee acquisition prediction system. Okay, so this and this IPYNB file I will be uploading to GitHub. I will be also uploading the readme.md for this and giving you the link so you can use it and like download it for yourself. And if you like, you can just share it with your friends who want to like start with machine learning because this is the first project and we'll be adding many more projects in this. And this was a pretty basic project for us to understand, and many more projects will be coming. Right now, you can share, you can like this video, you can just comment if you like something or you didn't like something or you want to understand something more clearly. So you can just comment out the things, and the this was from my side, and like thank you for listening.